So the next unit, the next topic is about quadrilaterals. Okay, and you know a lot about quadrilaterals already. You know squares and rectangles and so on and so forth. But in high school geometry, we're going to dive into those quadrilaterals and really look at all their properties, how do the diagonals relate to one another and interact, and opposite angles and interior angles, exterior angles, all that fun stuff. But we first need to come up with a good, solid foundation of vocabulary so that we can talk about these shapes and these interior angles and sides and so on and so forth. So I want you on your piece of paper to draw a quadrilateral that looks similar to this, but make sure that you label the vertices the exact same, because we're going to start listing out these angles and these sides, and we all need to be on the same page. So then draw this quadrilateral. So in general, if all that you're told is that it is a quadrilateral, you cannot assume anything about this shape. We can't assume that it's a square and has 4 congruent sides and 4 interior angles, or so on and so forth. If all I tell you is that it's a quadrilateral, then all we know is that there's 4 interior angles. What are those 4 interior angles going to add up to be? Four interior angles of any quadrilateral are going to add up to be what? We just took a quiz over this, folks. 360 degrees. N minus 2 times 180. So 4 minus 2 is 2. 2 times 180 is 360. So we don't know what these individual angles are here for this quadrilateral, but I know that they have to add up to be 360. For what the exterior angles, what are they going to add up to be? 360 degrees, because every single polygon, the exterior angles are going to add up to be 360. So we do know some things about this quadrilateral, but not very specific details. So every single quadrilateral has 4 sides. There are 2 pairs of opposite sides. 2 pairs of opposite sides. Now when I say sides, we know that the sides are what geometric object? They're segments. Okay? So when you are labeling this, then you need to make sure that your notation is correct. Now, I'm going to be writing all over this board, but you need to organize your notes how you see fit. I don't know if you drew this in the dead center of your piece of paper. I don't know if you drew it to the left or the right or wherever. But I'm going to be listing off a bunch of things on this board, and it needs to end up on your piece of paper somewhere. Okay? So we're first going to talk about opposite sides. Because when we get into these special quadrilaterals like rhombi and trapezoids and so on and so forth, these terms are going to come up in the definitions. So opposite sides. Every single quadrilateral has 2. So there's 2 pairs of opposite sides. The first being, you can have segment GE and segment MO. Those are 2 sides that are opposite. Segment GE and segment MO. And what is the other pair of opposite sides? Segment GM and segment EO. That's another pair of opposite sides. They are across from each other in this quadrilateral. They are opposite sides. The next term we're going to be using to describe sides is consecutive. What does consecutive mean? If you were to hear that just in any way, your English class or a history class, or what does consecutive mean? Continuous, I think that's what I heard someone said that. What's up?
It's like constant.
Okay, so one after another. So what you need to do is, in order to identify the consecutive sides, there's 4 pairs of consecutive sides. Every single quadrilateral has 4 pairs of these. You need to start at one side and then just go either counterclockwise or clockwise around your shape, and then just list the sides that are next to each other. So if I wanted to start here at segment MO, let's say I just wanted to start there, and I'm going to go counterclockwise. So segment MO is consecutive to this segment here that's next to it, EO. Well, now if I start at segment EO, and I were to continue going around counterclockwise, then segment EO and this guy, GE. Those are right next to each other. Those are consecutive. Well, now I'm at segment GE, and if I keep going around counterclockwise, what's the next shape, or what's the next side? What's the next side if I keep going counterclockwise? This isn't going to work if you guys don't respond. It's going to take forever. No matter what, that's your homework. Whether we get through the notes or not, that's up to you. Alright, I'm here at segment GM. Okay, we're at segment GM, and the next one will be segment GM. That's right next to it. And then the next will be segment GM and MO. Those will be the last one. Okay, now it doesn't matter that I went counterclockwise. We would have still got the same 4 pairs of consecutive sides if we would have went the other way around. So if I would have started at segment GO and then segment GM, well, that's the pair of consecutive sides I have in black ink. And then here, GM and then GE, that's what I had in red ink, so on and so forth. So we would have got the same exact 4 pairs of consecutive sides. But you need to be able to identify these. And the first quadrilateral we're going to talk about today is a kite. And in the definition, it has consecutive sides, so you need to be able to identify these. The same thing works for angles. Okay, you have your opposite angles and you have your consecutive angles. For opposite angles, okay, so what I'm going to do is I'm just going to erase this and replace sides with angles. Okay, so don't erase your notes. You just need to add to it. So opposite angles. Every single quadrilateral has 2 pairs of opposite angles. Can someone name me one pair of opposite angles? Angle G and angle O. And then the other pair? Angle M and angle E. Now sometimes your opposite angles will be congruent, sometimes your opposite angles will be supplementary, sometimes there will be no relationship at all, but you need to be able to identify your opposite angles. Then, the same concept with consecutive sides, we're now apply that to consecutive angles. So these are angles that are right next to each other. So in order to identify these, we're going to use the same method. I'm going to start at one of the angles and just keep going around. I'm going to choose to go clockwise this time. So I'm going to start at angle M. If I'm traveling around this quadrilateral in a clockwise manner, and I start at M, what's my next angle? What's consecutive to it? Angle G. But what if I start at angle G and I go around? What's my next one? Angle E. If I start at angle E and go clockwise around, what's my consecutive angle? O. And then the last one, the last pair of consecutive angles in a quadrilateral.
Angle O and angle M.
Angle O and angle M. Alright, so you got your consecutive sides, consecutive angles, opposite sides, opposite angles. Okay, once again, there's just some like general facts. You got some general facts about quadrilaterals, and those are things that I said earlier, that your 4 interior angles are going to add up to be 360 degrees. Your 4 exterior angles are going to add up to be 360 degrees as well. I can't really think of anything else that the general facts. But that's, I mean, if you have a quadrilateral, you do know those things for sure. Okay, then we're also going to draw in our diagonals. Every single quadrilateral has 2 diagonals. So 2. Every single one has 2 diagonals. For this this shape, named this way, are my diagonals drawn in right now? No, they're not drawn in my diagram, but can we add them in? Yes, there exists diagonals. Between any 2 points, there exists a line. So you are allowed to draw those in. Those are called auxiliary segments. So I'm not changing the shape at all. I'm just adding in a new segment. And I know that between any 2 points, there exists a line or a part of a line, so a segment. So I've got segment EM, and then my other diagonal in this quadrilateral would be segment GO. Now sometimes your diagonals are perpendicular, sometimes they're congruent, sometimes they bisect each other, sometimes they're perpendicular, all kinds of fun stuff. Just depends on what shape you have. So any questions about just the very basic information about quadrilaterals, diagonals, consecutive angles, and sides. Do you have any questions? Okay, on the next page, you're going to be drawing two quadrilaterals. They're both going to be kites. But you're going to draw them. I would draw one on the right-hand side and one on the left-hand side. We're going to be adding to both of those kites, but I mean, I would just kind of split it off. One's going to be looking like this, K-I-T-E, and then on the left, I want you to draw one that's labeled A-B-C. Now, it would make sense to have it in the same orientation as I do, just so we can all be on the same page. But here's your second diagram right here. So both of these are kites. So if I were you, I would draw a line after we just got done talking about the just the general facts about quadrilaterals. And now this is a kite. If you look at the very, 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 very top of the board, there is the definition of a kite. So we're going to go ahead and write that down together. A kite is a quadrilateral with exactly two distinct pairs of congruent consecutive sides. Why is this word important right here? Distinct. It's got to be two distinct pairs of congruent sides. What are they saying can't happen? There has to be a clear difference between these two pairs of congruent sides. Because what happens if they're all congruent? What shape would that be? You don't know anything about the angles. You don't know anything about the angles, but what's a shape called? Quadrilateral with all congruent sides. And that's it. Four-sided figure. Yes, I'm asking what is a four-sided equilateral polygon? I swear, you don't know anything about the angles. What is it?
Quadrilateral?
Nope. Quadrilateral is just a generic term. There's a special term for when it's equilateral. The quadrilateral is equilateral. It's not a diamond. Oh, that's not a real quadrilateral. Huh? Rhombus. Rhombus. If all you know is there are four congruent sides, that's all you know, it's called a rhombus. If it's four congruent sides and four congruent interior angles, that's when you have yourself a square. But anyways, that's why it has to be distinct. They can't be the same. If they're the same, then you get yourself a rhombus. So this guy's kind of off on its own. If you look down here, you need to copy this down. So if I were you, I would write quadrilateral, K-I-T-E, with segment K-I, congruent to K-E, and segment IT, congruent to ET. So this is what we know. But they're distinct, so that's why I'm having to put one mark of congruency on one pair of congruent consecutive sides, and then 2 marks of congruency on the other pair of congruent consecutive sides.